This exercise is 2-in-1. In both parts A and B we have the same, or apparently the same, system of linear equations, two equations and two unknowns, but one time we consider it over the field of real numbers R, and in part B we consider it over the integers modulo 5, what we call Z5, which is a finite field containing just 5 numbers. Now, if you don't know what this means, then you probably don't want to be in this exercise, and feel free to just go. But so I'm assuming that you've studied these fields. In general, it's not just with a 5, it could be any prime number p. Okay, but part A is just completely regular. So we're going to do it with matrices and with the Gauss elimination method. The matrix part is standard. I want to bring it to echelon form, and normally I might do something like subtract half the first row from the second, but I don't want to mess with fractions, so the easier thing to do is just to swap these two rows, because a 1 is easier to deal with. So yeah, that's just what we switch the two rows around. This is what we get. And now what we want to do is subtract twice this row from this row. And there's a notation, and this is how we write the notation for what I just said. And the result, I'll leave you to check the computations, just like 2 minus twice 1 is 0, and so on. 3 minus twice 4 is minus 5. Okay. So this is now in echelon form, at least the restricted matrix. This whole thing is the augmented, remember, and just this part is the restricted. So now we do what I usually do when I see a common factor. It's not mandatory, but it's nicer to work with smaller numbers. So divide by minus 5 on the bottom row, and doesn't this look much nicer? Okay, so it's time to go back from matrix to SLE. I don't think any explanation is necessary. And now we do what we call the backward substitution. Well, y we have already, so we substitute it here. I mean, y is 1, so we take this 1 and substitute it instead of y here, and this top equation becomes this. From here, x is 2, so now we have x and y. And this is a solution written nicely in a box. Okay, but that was part A with the real numbers. Let's see how much is similar and how much is different over the field Z5.